one other piece of the process FMEA, again, you've seen the template that we use. Um, as John said, it tries to identify potential failure modes, what could go wrong, and what are the effects to the process, to the device, if that failure mode occurs. It's all well and good to write down what the potential failure modes are, but you have to try and bound that within a certain sense of reality, because you could go crazy. Well, what are all the things that could go wrong? Well, I don't know. A meteor could hit the building and we wouldn't be able to build product. That's a problem. So
But the
what the
occurrence is
PFMEA,
low in that one, so we're good.
well, and that's what I'm getting to. So what the PFMEA does is it tries to quantify these failure modes, and what it does that by using an RPM number.
It's a number that the bigger it is, the more dangerous, more likely, and the bigger that number, the more you're going to want to mitigate it.
Right. And what the RPN number is, it's a formula. So the RPN is equal to three different variables. One being the severity of the failure mode. How severe is that issue if it fails? Is it not a big deal at all? Or is it a major catastrophic deal on a scale from 1 to 10? Then you have your occurrence, which is basically saying, how likely is this failure mode to occur? How likely is it to happen? Is it 1, not very likely at all? Or is it 10, extremely likely it's going to happen? And then the third number is what we call detectability, which is the ability to see that failure. Is it very easy to spot, or is it not easy to spot at all? And what we, the engineers conducting this PFMEA, will do for each potential failure mode, we'll rank those three variables with a number. 1 through 10 is the general scale. Multiply those three numbers, and we get an RPN number. And to John's point, there's a triggering value. In most cases, we use around 200, but in some cases, we'll bring that number down to 100. In some cases, we'll move it up. But once we've identified what that RPN number is, and we have these failure modes, you multiply the three numbers for severity, occurrence, and detectability. If it's above that threshold, well, now you have to do something about it. That is a required effort that you need to take to mitigate that failure mode in the process. So if you have a failure mode where the severity is very high, if something fails, if this failure mode happens, it could kill someone. Well, that's a high severity, so we would rank it a 10. And if it's very likely to happen, we would also rank it an 8, a 9, or a 10. And you can see how it's kind of compounding, but then, you know, the detectability is very low, which would flip the scale. So that also would be a 10. So then you take 10 times 10 times 10 is 1,000. Well, now you got a problem. You need to mitigate that risk.
And really, in certain things, like say a medical device, if the severity number is high enough that someone's getting injured, then it almost doesn't matter how often it occurs. You've got to do something to eliminate it. So that's another kind of facet of so in a process FMEA, it's how you're assembling those parts. Let's hope the design's already gone through the DFMEA, right? So there's not going to be anything that's going to kill anybody because, you know, a part broke. But if we fail to install it, or think of an aircraft, when you put the oil filter on, your car, you just tighten it up, start the engine, and off you go. Well, when you do it in an airplane, you have to safety wire the filter in place so that under the vibration, it can't back out. Because when you're in an airplane, you can't just pull over, add more oil to the engine, and put a new filter in place. So So a PFMEA depends upon, what's the severity if this filter comes undone, and the process of changing the oil and installing the filter, you would want to safety wire the filter in place. It's a similar kind of thing with other products. You have to look at the severity, and then look at the conditions that the product is being used in, and make sure that you're not going to have a failure mode that could cause catastrophic damage.